Hi, my name is MUSHON ZER-AVIV, and today I'm going to speak with you about the normalizing machine. Thanks for inviting me. I'll speak a bit about the history behind the work, and then kind of the prospects for artificial intelligence and face recognition and bias for the past and the future. So, like everything, it's going to be separated to three. We'll start with criminalizing the face. We'll talk about algorithmic normalization, and then I'll try to suggest the prospect for simple AI. So first, criminalizing the face. So let's go back to the late 1800s in Paris, where we saw a lot of new people coming into the city, people that didn't live in the city in the past, and a lot of unrecognized faces started to flood the streets that previously used to be, you were surrounded by people that you knew. So, and that was a problem for the police as well. The police started to use photography when they arrested people, but they didn't necessarily know if that person that they just arrested is indeed Philippe Drejoli, whoever he might say he is, or if it's indeed the very notorious criminal Ravakol. This person, Alphonse Bertillon, was a police officer, a son of a statistician, and it was a problem for him because he had a lot of pictures, but no way of sifting through them. There was no way for him to go through all of these pictures and identify the person standing in front of him in the picture. And he invented something that we all know. He invented the mugshot, and basically began the standardization of police photography and forensic photography. So he created these cards, the mugshot that we know now, but he tried to really measure and turn into data everything that he could about the arrest and about its photographic evidence. And that was quite a revolution. The system that he developed was called after him Bertillonage. And as you can see, he measured not only the face, but different parts of the body. And one of his main inventions was this table, which he called Le Tableau Symbiotique des Traits Physionomiques. And he also referred to it as the portrait parlé, the speaking portrait. So if the person that we just arrested wouldn't speak, their portrait would speak. So he collected many types of noses, many types of mouths, many types of eyes and ears. He was really into ears, really kind of sunk into the ear. And he was interested in indexing all of these types in order to create a system for identifying people. So if you had this nose and this ear, I would look for you on that folder. And that's where I may find that you were arrested in the past and make sure that you are who you say you are. The system, the Bertillonage and the portrait parlé, have really propagated around police stations all around the Western world, and they become the way of identifying criminals and working with forensic photography. So you could see that really in Europe, in the US, and that has become, and we know it until today with the mugshot, but that specific system was the way to work, at least until this came into the scene. The fingerprint. Obviously, the fingerprint was a much more efficient and precise way of identifying specific people. But that was not the end of the Bertillonage, because this person, Francis Galton, was very interested in Bertillon's system. Francis Galton was Darwin's half cousin, and he read the theory of natural selection in a bit of a different way. So he took Darwin and natural selection and he as a prescription rather than an analysis. So he looked at it as a basis for how society should evolve. And he developed, he coined the term eugenics and advocated for what he called responsible breeding. Eugenics have become kind of a lifestyle, different communities advocating better baby breeding. They had this better baby context, and they used Bertillonage as a way of measuring whether the society is indeed moving towards something better. They advocated against breeding with defects. Even something as minor as a slit lip was considered something to fight against, and avoid breeding, continuing these defects into evolution. This was basically the basis for social Darwinism, a racist interpretation of survival of the fittest. So you can see these forced sterilization laws that were very kind of propagating not only in Europe but very much in the US in the beginning of the 20th century, were really focused. Some people are born to be a burden on the rest, so let's make sure that they don't even breed. Obviously, the Nazis were really into that. This person suffering from hereditary defects cost the community 60,000 Reichmark during his lifetime. Fellow German, this is your money too. So definitely don't allow these people to even be born if it's possible, right? So this perception of analysis of the body and the face as the basis, it has become not only the basis for identification, but for categorization and analysis of character and of value. Back to Bertillon, he was saying he was not actually convinced of that. He said, I do not feel convinced that it is the lack of symmetry in the visage, or the size of the orbit, or the shape of the jaw, which makes a man an evildoer. As far as he was concerned, it was just meant for indexing. But obviously, it was not the way it was used. So Act 2, let's talk about algorithmic normalization. Another person, important figure from history, Alan Turing. Alan Turing was a British mathematician. He's most known for inventing the Enigma machine during World War II. The machine was used by the Allied forces to decrypt Nazi messages from their U-boats, and these Enigma code breakers have become the unsung heroes of World War II. Their work remained secret until many years after the war, and it is said that the work that they did shortened the war by maybe 2 years. So the work they did in analyzing and decrypting messages saved millions of lives. After the war in 1950, Turing continued into research around machine intelligence, and he's considered the father of artificial intelligence. In a prophetic essay from 1950, let's actually look at this clip.
and in 1950 he published a prophetic essay. I propose to consider the question, can machines think? This should begin with definitions of the meaning of the terms machine and think. The definitions might be framed so as to reflect as far as possible the normal use of the words, but this attitude is dangerous.
So as a part of his work on understanding what machine intelligence could be, he really dug also into what does intelligence even mean. So he developed something that he called the imitation game, or later called the Turing test, and that has become the gold standard for artificial intelligence. The way it would work is you would have two conversations. A human would have two conversations, one with another human and another one with a machine. And that person would need to identify who's the human and who's the machine. When the human failed the test, that's when the machine passed the Turing test. So from the very early ages of artificial intelligence, the standard was about fooling humans in a way. Another thing about the life of Alan Turing, he was also not so secretly homosexual. And he was, in 1952, he was convicted of homosexuality and was chemically castrated. And then in 1954, he ate a cyanide-laced apple. The type of systemic, the systemic bias and systemic subjectivation that he suffered was something that throws another perspective on his life work. In his writing, he talks about the child machine. He was saying it will not be possible to apply exactly the same teaching process to the machine as to a normal child. So if we think about this machine as a child, how can we think about teaching that child machine? Further on, he was concerned about we cannot send the creature to school without the other children making excessive fun of it. So he was concerned for the feelings and how would that child be looked at by other humans. But if we fast forward to artificial intelligence today, we see that the problem is actually the other way around. It is the machines that are in charge of looking at humans or propagating that systemic bias that Turing himself was the victim of. In 2017, Stanford researchers trained a neural network AI system to identify gay faces. They wrote, "We're really disturbed by our findings. The accuracy of an AI system can reach 91% for homosexual men and 83% for homosexual women." The study also concluded that homosexual men and women tend to have gender atypical facial morphology, expression, and grooming styles. So now it's not the child machine who's the victim of systemic bias, it's the other way around.
A startup company based in Tel Aviv says it has developed software that can identify terrorists and other criminals based on their facial features. Faceception's learning algorithm program uses 15 classifiers and genetics to uncover an individual's personality traits.
We see many signals in the face, which are coded from the DNA. And this is a way we can make analysis or personalization of anyone.
Analysis or personalization of anyone. Definitely startup nation galore. Not very proud of that aspect of my country. Now, we can think, what is new? Like we have how humans look at humans. What a human can say, can look at another human and try to understand, do I see a face? And if I see a face, do I recognize this face? And even if I don't recognize this face, does this face seem okay, right? These are things that we're doing all the time. This is a part of how we look at humans. And if there's one thing that our visual perception is really good at, is looking at faces. When a machine looks at human, it's pretty similar, right? Face detection, do I see a face? Face recognition, do I recognize this face? And face analysis, does this face seem okay? So what is the difference? What might be the problem with face recognition when we're talking about how machines are looking at humans? I would say the difference is this, the eyes. I think the eyes are critical. The eyes are a part of our face. They're not separate. We have this type of systemic power, right? The kind of photographs taken by the police, the kind of photographs that that Bertillon went ahead and made some made some systemic guidelines for. We don't see the face of the policeman that is capturing that picture, but we definitely see the image of resistance. We definitely see that there is relationship with between two people, even though we don't see both their faces. We know there are two faces, two humans in an antagonistic relationship captured by this picture. This is exactly what is missing from this type of capturing. The kind of capturing by surveillance cameras or other types of disembodied gaze, right? It's not only capturing much more, it's also hiding the conflict. It's depoliticizing the power relations. And that's where the problem lies. And that's also why I think we should look at sinful AI. And this is also where the work, the normalizing machine, is trying to respond to. Michel Foucault wrote, if you are not like everybody else, then you are abnormal. If you are abnormal, then you are sick. So these three categories, not being like everybody else, not being normal, and being sick, are in fact very different, but have been reduced to the same thing through this systemic bias. In this recent article, we can see that the kind of algorithms that are predicting crime that are really propagating and being used all over the judicial system, when they're tested, they're not very much better than untrained humans. So they're supposed to be this scientific methodological expertise that is using a lot of data and turns that into knowledge that can empower decision making. At the end of the day, what it often does is recycle a lot of the bias in a way that is just hidden behind the scenes. And that's where I want to talk about the normalizing machine. The normalizing machine is presented as an experiment in machine learning and artificial prejudice. In a way, we want to teach machines, how does a normal person look like? It's presented as every participant steps into the gallery and sees two portraits and is asked to point at the one that looks more normal. Let's look at that. So this is from Ars Electronica Festival, pointing at the one that looks more normal. It goes through 5 rounds. In each one, the participant points at either left or right. And in the final round, as you can see, they're asked to choose between themselves and another person to decide who's more normal. The result is then used to create these arrest cards, automatic arrest cards, just like the ones that Bertillon created, and fill their data inside. These cards later feed the portrait parler table, that kind of automatic portrait parler table that we can see here. So basically, we have this. What we try to do is to kind of complete the system that Bertillon started, to complete it with the added kind of history of how a system of indexing have turned into a system of analysis and automation of not only face identification, but face classification and automatic bias. Georges Cunilem wrote, "The abnormal, while logically second, is existentially first." And that's also one of the reasons why we actually ask people to point at the more normal. When we are asked to point at someone normal, who's more normal, what we're actually doing is we're trying to understand what's less normal about the other one. So pointing at the normal is basically pointing at the abnormal. So we had a lot of people participating. This is just a small selection, and it's really interesting to see how they see themselves, how they see each other. But what we found to be especially interesting is these ones. The ones who actually decide not to participate. And every now and then when we see people kind of hesitate next to the installation, we ask them, do you want to try it out? And very rarely, but every now and then we would have someone say, I don't want to be a part of it. And this is probably the best response this installation can get, because that's when people get it, even before experiencing it themselves. This idea that this is a system of subjectivization and bias that I don't actually want to be a part of. And in an installation in a gallery, you can indeed stand in the side and decide not to be a part of it. But when we're talking about the propagation of these technologies and this culture outside of the gallery, can we really choose? Because this normal abnormal is happening all the time, right? It's happening with dating apps. It's happening with every like that we live everywhere. It's obviously happening on Instagram all the time. And it's even happening with every swipe and every tap that we live. It's all constantly creating this growing image of what is a normal behavior, and based on that, what is abnormal, and how can we identify and subject people based on this algorithmic image of normalcy. So if we look back to the history, we can see that it starts with the subject. That subject is then captured and turned into data. That data is accumulated into a data set that allows both identification and categorization. Both of these feed into a model, and that model is the basis of an analysis, right? An analysis like we've seen with the eugenics movement. That analysis feeds back into the model, informs the model, and then becomes the basis for action. So it doesn't stop with analysis. It actually leads to things that happen to people in the real world. And you would see that this was with us back then. And this is exactly the system that we have right now. Because now we have, again, subjects these subjects are captured in a much more efficient and much more dehumanized and depoliticized way. It's turned automatically into data in a much more efficient and much more automatic way. The data sets are much bigger, and they're propagating way beyond we could see. Again, it can be used for identification for the world of wonders that is the pleasure of having your phone unlock by identifying your face. This is definitely a life-changing invention. But it's also used for categorization. It's also used to say, this is normal, this is abnormal, this is good, this is bad. This should get parole, this one shouldn't get parole, this one should be hired, this one shouldn't, and so on. These feed into the model, a model that may say gay, straight, and that that is the basis for an analysis, like we can see, like the analysis we can see with the Chinese social score that has become a huge controversy around how you actually manage the masses. The analysis feeds back into the model and definitely leads to action. It can lead to the decision whether you would go free or spend more time in jail. We have taken a system that has history. It's important to remember. Obviously systemic bias, but also this whole process of the datification has a history, but we've made it more automatic, more opaque, and less political. We've moved this decision-making behind the scenes, and this is probably where the main problem lies. So it's not only about face analysis. It's also about identification, but also affect recognition, like emotion detection that is used in classes, in job interviews, and in public housing. The bias is not necessarily technological. It is systematic. It is how we expect that certain, again, there is the normal way of how is a job applicant supposed to look and function, and there's and then because these are tough decisions for humans to make, we just outsource them to the machines, where we keep on thinking that this is it's okay because it's not us, it's the machine is doing that. This is scientific, this is technical. But we can track bias in every step of the way. There's no single process here that is not biased. These tools are, Kate Crawford from the AI Now Institute wrote in Nature magazine that these tools are dangerous when they fail and harmful when they work. So it's not only about failure in the process. It's even when they work the way they were meant to work, the way they were meant to work is often problematic. It underlies this unjust system that they serve. Like the system itself, our political system is biased. It's not only the algorithm. So it's not only about debiasing the system. In a way, we need to move from a framework of debiasing into a framework of justice, which takes into account not only the technological system, but the social system. And we can see that starting to happen. We can see the GDPR is definitely a step towards inserting public interest in technological systems. And while there can be some critique about its not being overpassing enough, or there are some holes in the GDPR, but it's definitely one of the most impressive attempts in inserting some public interest in these systems, and it has a very positive effect. But we can see that not only in Europe, San Francisco, the city where so much of these technologies are developed in the Bay Area, San Francisco bans facial recognition technology. So they understand it well enough to understand that they need to ban it. And it moves in Congress towards banning facial recognition in public housing. And also in the Far East, we could see protesters in Hong Kong using both face masks before COVID-19, face masks and lasers to protect themselves against surveillance cameras and face recognition. Well, all models are wrong, and some models are useful. This is an important thing to remember about every model, definitely the models that are fed into artificial intelligence. But so we need to remember that AI may be useful, but it is not seamless. It is sinful. We need to look at the sims. We need to look at the traces of humans and a human process and a social process to really understand the effect of these systems and to find the right place within culture. Thank you very much.